This is an Algebra 2 class where we're going to look at adding rational expressions, adding or subtracting rational expressions. Whenever we add or subtract with fractions or rational expressions, we need to have common denominators. If the rational expressions already have the same denominator, all we need to do is add the numerators together. So since our example in number 1, both have a denominator of 4x squared, all I need to do is add our numerators. So I get 3x plus 5 over 4x squared. In our next example, they also have a common denominator of x squared plus 1. So we're going to add our numerators together. So we have 2x squared plus 2 over x squared plus 1. On this one, we want to look to see if it reduces or simplifies. Our first one didn't simplify because our numerator was factored as far as it can go and there were no common factors. But in this one, our numerator has a common factor of 2. So we can factor out the 2, leaving us 2 times the quantity x squared plus 1 in the numerator and x squared plus 1 also in the denominator. We have a common factor of x squared plus 1, so those two reduce, leaving us with a final answer of just 2. In our next example, we have subtraction. It works the same way. We have a common denominator, so we're just going to subtract the numerators. So 4x minus 1x is 3x over x minus 2. This can't be factored any farther. The x minus 2 is a simple binomial with no common factors, so it can't be reduced any farther or simplified any farther. Number 4, again, we have common denominator, so we just need to subtract our numerators. Be careful with this minus. This subtraction goes to the entire numerator, so each term up here is going to be subtracted. So we'll have x squared minus 2x minus 3 all over x minus 3. Let's check to see whether or not we can reduce this one. Let's factor, if possible, x squared minus 2x minus 3. So as I factor that, we have x times x, multiplying to get negative 3 is negative 3 and 1, and those two add up to negative 2. So this factors. We have a common factor which reduces, leaving us with x plus 1. What happens if the denominators are not the same? Well, then we need to find our common denominator, our least common denominator. In order to find our least common denominator, we need to look at the factors of each one of these. The factors of 4x can be 2 times 2 times x. And the factors of 6x would be 2 times 3 times x. When we build a common denominator, we need to take each factor of the terms and put it in the least common denominator. They share a factor of 2, so I'm going to put a 2 in the least common denominator. Now, I still need to have all of these factors in my denominator, so let's combine those. We need another 2, and here we need another 3. And notice they have an x in common, so let's put a single x in here. As I look at those, I can see that each denominator is completely represented in the least common denominator. This one of 2 times 2 times x is right here, 2 times 2 times x. And 6, which is 2 times 3 times x, is also represented with 2 times 3 times x. That turns out to be 12x as our least common denominator. Once I have our least common denominator, I need to change each fraction so that it has the common denominator. So if I take 3 over 4x, and I want this denominator to be a 12x, I need to multiply it by 3. So I'm going to multiply the denominator by 3 and the numerator by 3. For our second fraction, we have a denominator of 6x, and in order to get our common denominator of 12x, I need to take the 6x and multiply it by 2. So the denominator and the numerator are each multiplied by 2. That gives us 9 over 12x plus 10 over 12x. Adding numerators gives us 19 over 12x, and there are no common factors, so it won't reduce any farther. On number 6, again, let's take a look at the factors of each of our denominators. 4 can be written as 2 times 2, and x just is x. It doesn't factor any farther. So I need one of each factor represented in my least common denominator. They don't have any factors that are the same, so our least common denominator is the product of all those factors, or 4x. So as I look at my fractions then, my 3x divided by 4, in order to get 4x for my common denominator, needs to be multiplied by x. Numerator and denominator by x. My second fraction, the denominator of x, in order to become the common denominator 4x, needs to be multiplied by 4. So we get 3x squared divided by 4x minus 12 divided by 4x. So we get 3x squared minus 12 divided by 4x. Now our numerator does factor, so let's see what happens when it factors and see if we have any common factors. 3 factors out of our numerator, leaving us with 3 times x squared minus 4 over 4x. And the x squared minus 4 is a difference of 2 squares. It can be factored into 3 times x plus 2 and x minus 2. We've got it all in factored form, and we look and we see there aren't any common factors. So we can leave it in this form, which is factored form, or we can go back to our simplified form. Okay. Let's take a look at some more ones that have more complicated denominators. So as we look at these, we have 7 over 9x squared plus x over 3x squared plus 3x. And we want to find our least common denominator. So let's take a look at 9x squared. 9x squared can be written as 3 times x times x. And then 3x squared plus 3x, we can factor out of 3x, leaving us with x plus 1. So when we build our least common denominator on this, we see that we have a common 3, so let's put that in. We have a common x, let's put that in. And now we need to have every other factor be represented in our least common denominator. So I need another 3 and another x, and I need an x plus 1. So our common denominator is 9x squared times x plus 1. Now, let's write out these factors here. We have 7 over 9x squared. It needs an x plus 1 so that it will have the common denominator. And our second fraction, let's write that in factored form, x over 3x times x plus 1, and look to see what it needs. Well, it has the x plus 1, it has a 3x, it needs a second 3x. So we're going to multiply numerator and denominator by 3x. So now let's write these two fractions. We have 7x plus 7 over 9x squared times x plus 1 plus 3x squared over 9x squared. 3x times 3x is 9x squared times x plus 1. They now have a common denominator, so let's add the two fractions together and the numerators. And our highest degree term, our first term, is going to be the 3x squared, then the 7x, then the 7. Over 9x squared times x plus 1. This trinomial, 3x squared plus 7x plus 7, won't factor, so this fraction will not simplify any further. Okay, let's do another one. We need to build our least common denominator. So our first fraction, or our first denominator, 3x, is 3 times x. And our second denominator has a common factor of 3, so we write it as 3 times the quantity x minus 2. In our least common denominator, we want to put in a 3, and then I need an x and an x minus 2. Each factor of both denominators is represented in the least common denominator. Okay, so now let's take x plus 2 over 3x, and it's missing the factor x minus 2. So let's multiply by x minus 2. And our second one, if I write the 3 times x minus 6 in factored form, I have the 3 times x minus 2. So I have the 3, I have the x minus 2, I need another factor of x in numerator and denominator. Now to add these together, I'm going to actually have to do some multiplying out. So I need to do first, outer, inner, last. When I do that, I have x squared plus 2x minus 2x, plus and a minus, and then minus 4 over 3x times x minus 2. And my other fraction is plus 4x. Adding those together, our 2x minus 2x are going to cancel out. So we're going to have x squared. Our next term is plus 4x. And then minus 4 over 3x times x minus 2. This trinomial won't factor, so the fraction will not simplify any farther. Let's do 2 more examples. We can do this. Okay, so 2 more examples. Got a little bit more room here. I'm going to actually do my factors right below the fraction so I can see them a little better. So our first one factors to 2 times x minus 1, the denominator 2x minus 2, common factor of 2 times x minus 1. Our second denominator factors into 2 binomials, x minus 3 and x minus 1. To get our least common denominator, we have our factor that we have in common, the x minus 1. And then I need each of the other 2 factors included. So times 2 times x minus 3. We usually write the coefficient first. So this is our common denominator. Okay, so let's take our first fraction, x plus 2, and our denominator in factored form is 2 times x minus 1. And I look at my common denominator and see that I need a factor of x minus 3. I have subtraction. My second denominator in factored form is x minus 3, x minus 1. And as I look at these, I see that I'm missing a factor of 2. So I'm going to multiply the numerator and the denominator by 2. Okay? So in our first fraction, when I multiply it out using FOIL, I get x squared minus x minus 6 over 2 times x minus 1 times x minus 3. And on my second one, do you see I've got this subtraction here? Let's see if we can switch it over before we even start multiplying. So we want to add the opposite. So we're going to have 2x plus 1 times 2, or 4x plus 2 over the denominator. They have the same denominator, the same 3 factors, so add like terms. We have an x squared. Negative x plus 4x is 3x, and negative 6 plus 2 is negative 4, and we have those. Now, this denominator, or this numerator, this trinomial, x squared plus 3x minus 4, does factor. It factors into x plus 4 times x minus 1, and our denominator 2 times x minus 1 times x minus 3. We have a common factor of x minus 1, so those reduce, leaving us with x plus 4 over 2 times x minus 3. And that's our simplified sum, or difference in this case, since we had subtraction. Let's do one more like that. Let's take a look at our two denominators, and we want to factor them. So factoring x squared minus x minus 12 is x minus 4 times x plus 3. And a common factor on 12x minus 48 is a 12, so 12 times x minus 4. Our least common denominator, we have an x minus 4 that they share, so that needs to go into our common denominator, an x plus 3 and a 12. So our first fraction, writing the denominator in factored form, we can see that the factor that we're missing to get our common denominator is a 12. So I'm going to multiply the denominator and the numerator by 12. In our second fraction, again written with a denominator in factored form, 12 times x minus 4, I look at my least common denominator and I see that I need an x plus 3. So in our denominator, x plus 3, and in the numerator, x plus 3. So let's multiply those numerators out. We have 12x over our denominator, 12 times x minus 4 times x plus 3, plus distributing 5x plus 15 over 2 times x minus 4 times x plus 3. And now that they have a common denominator, we're adding like terms in our numerator. So 12x and 5x is 17x plus 15 over 12 times x minus 4 times x plus 3. It doesn't factor in our numerator, so here is our simplified form of our fraction. So that's adding and subtracting with rational expressions.